Thanks, it's great to be here. Good morning. I don't need to tell any of you that we're living in a moment of an AI and data science revolution. Many of you are driving that revolution at your organizations. Many of you are feeling buffeted and disrupted by it. But whichever side of that you're on, I think we can all agree that there's a revolution taking place. You've heard before what the causes of this revolution are. More data than ever before, more diverse kinds of data coming from financial transactions online, from social media, from these supercomputers that we all carry in our pockets, and so on. Cheaper storage means massive amounts of data can be saved for later use. More powerful computers and incredible new computing techniques like machine learning are making it possible to do things with all of this data. What I want to focus on for the next few minutes with you this morning isn't the causes of the data revolution, but what some of the consequences and implications of this revolution are that are either going to threaten our businesses or, if we can figure out how to exploit them, allow us to achieve greater competitive advantage and market share. But first I want to say a word about what's new. Because data analytics has been around for decades. We've had data for decades. Just ask people in fields like banking and insurance that have been doing sophisticated analytics on massive amounts of data for many, many years. That's not what's new. But what is very new is the emergence of machine learning. And machine learning changes everything. Machine learning refers to a programming approach where instead of writing the sort of do this, then do that kinds of computer programs that were popular a few years ago, we now have computer programs that can learn from the data. The computer program has a set of variables or parameters whose values are determined when they are trained by a data set. And the reason why this changes everything is because now we have the ability to develop programs that can do things way more complicated than any human mind could have created. It also means that these programs aren't going to be so susceptible to the prejudices and biases and domain knowledge that we bring. Instead, they're going to agnostically learn from the data. Of course, as the joke goes, what could possibly go wrong? And as we know, with this power, a lot can go wrong. And what's emerged from that is a major area of research to try to make these machine learning algorithms safer and more reliable, even when faced with a set of input parameters that they never anticipated. Let me share a few examples of what I mean when I talk about the implications and consequences of this data and AI revolution. Data mining and data analytics means we can go deeper into the data and extract subtle features that might have previously been hidden in the noise. As I'll describe in a minute in more detail, we're now seeing the emergence of techniques that allow us to get value from unstructured and semi-structured data. The field of clustering and segmentation allows us to take a large population and divide it into smaller groups that are much more homogeneous. And of course, once you've identified those small groups, you can do things that are tailored to those groups. You can think about clustering and segmentation as a baby step toward hyper-personalization, where we are all our each own segment. We're making increased use of time series data from sensors, from the Internet of Things, from these supercomputers in our pockets. And I'll talk a little bit about some of the new analytical opportunities related to time series data. And advancements in cybersecurity are allowing us to do sophisticated calculations in the cloud without having to disclose the private data that the calculations are based on. Let me share a few more of these high-level themes and consequences with you. Natural language processing, the ability of computers to understand normal spoken and written speech, has made tremendous strides. I'll give you a few examples in a minute. And computers are now developing the ability not just to understand what we say literally, but the sentiment and the emotion and the intention behind it. Computer vision, of course, is touching everything and has gotten a whole lot more sophisticated than just finding pictures of cats on the internet for us. And I'll say a few more words about that as well. We're seeing the emergence of machine learning algorithms that incorporate physics, rules of how the world works, and that allows the range of possible answers to be constrained. We're seeing the rise of statistical and probabilistic approaches that are often more accurate than the deterministic approaches they're replacing. How can that be? It's because of the power of the massive data that they're based on. The development of continuous learning and dynamic models and techniques called reinforcement learning are allowing algorithms to change and evolve and learn in real time. So, for example, future autonomous vehicles will learn based on what happened a moment ago to not make the same mistake again in the future. As I mentioned a moment ago, we're seeing emergences of new technologies to make these sophisticated systems more robust and reliable. My colleagues call that AI safety. And AI safety involves techniques that can verify that systems are working correctly, that can lead to explainable AI systems that don't just make a recommendation, but explain some of the nuance and subtlety and assumptions that were behind that recommendation. You can imagine how important that is if a computer is recommending an investment decision or a medical, therapeutic, or diagnostic procedure. And finally, we're seeing the development of robots that can work in unpredictable and complex environments, like disaster scenarios or cleaning up our kitchens. So what I'd like to do for the next few minutes is take 4 specific examples from that list and go a bit deeper and give you a sense of what the technology is really like under the hood. And then I'll wrap up by trying to relate all of this to business, industry, innovation, and entrepreneurship. First, I want to talk about unstructured and semi-structured data. Computers, for a long time, have been very good at structured data, things like relational databases and flat file spreadsheets. But most of the data that's important to us, that we consume, isn't like that at all. It's completely unstructured, like free-form text, or semi-structured, like those tables and charts and graphs that are in financial reports or sporting reports or things like that. And fortunately, new techniques are allowing computers to read these unstructured and semi-structured forms of data increasingly accurately and increasingly with the same effectiveness as structured data. This is the work of a colleague of mine by the name of Christopher Wray and his coworkers. And the idea is to be able to take this data that computers were previously blind to, things like handwritten charts, images, figures, and so on, and turn it into the kinds of things that computers can read. Tabular data, histograms, these spider web-looking things that describe how elements in social networks and other kinds of networks interact. And if we can do that, we can make all of the normal, human, unstructured data available to computers. This has been applied successfully during the last few years in a variety of environments at a variety of organizations. For example, using reports to determine the efficacy of different kinds of medical devices, using electronic health records to try to understand what correlates with better or worse outcomes from medical procedures, social media data to try to understand where terrorism comes from. And in a particularly remarkable example, this software is the engine underneath a project called MEMEX at the United States organization called DARPA to fight human trafficking on the web. And this is such a remarkable example, I want to go into that in a little more detail. Human trafficking, of course, is a human rights disaster. And the goal of this work was to see if it would be possible to identify the traffickers and go after them. The internet, for all the good that it's done, has also helped people who would do bad things at society, like human traffickers. This software was used to crawl 100 million ads on the internet advertising sex services. We should all pause for a minute to contemplate the horror of there being 100 million ads for sex services on the internet. And the software was used to extract as much data as possible from these ads: phone numbers, geographic locations, names if you were fortunate enough to find them, services, prices, and so on. But the federal government demanded that there was the ability to distinguish between likely trafficked individuals from so-called voluntary sex workers. I say so-called because we can all question whether that really is a voluntary choice or not. But from a legal point of view, it's a clear distinction, and they wanted to go after the traffickers. And you'll smile a little to hear this next story. It turns out they were able to distinguish the trafficked from the non-trafficked individuals by looking at the prices charged for particular advertised services. It turns out trafficked individuals charge less. But to get that right, they needed to use federal government data from the National Bureau of Labor Statistics on unemployment rate and how it varied geographically across the country, so they could normalize the data to the local price points, labor rates, and unemployment rates. A somewhat ironic combination of federal statistical data with illicit activity data. And the quality of the data is so good that it's now being used for both investigation and prosecution in several parts of the United States. This ability to get at unstructured data and produce rigorous, high-quality results is an important thing for all of us. I now want to switch gears and talk about time series data, data that's moving forward at a continuous rate from sensors, from transportation, from the Internet of Things. Time series data is a challenge. It can be high dimensional, many different variables. It's often unlabeled, meaning you don't know what the different states of the different variables might be. It's moving by quickly. It's changing all the time. The work that I'm going to tell you about here is work from my colleague Peter Bayless. And the question that Peter and his students asked was, can we identify the anomalous data point in time series data, the needle in a haystack, and can we do it in real time? So if the data is going by at megahertz rates, can we pluck the anomalous data point out in a microsecond? Because if we can do that, we might be able to shut down a piece of equipment before it damages itself. Or we might be able to do real-time fraud detection of credit card transactions. Let's pause to think for a moment about what an anomalous data point even is. In one dimension, we all have a great intuition about it. There's a region where most of the data is, and then way out here is the outlier. That's the anomalous data point. Even in a few dimensions, we can imagine a cloud where most of the data is, and then a data point off some distance away from the cloud. But what if you have hundreds or thousands or tens of thousands of variables and degrees of freedom? And what if they depend on each other in complicated and time-varying ways? Then it isn't even obvious what we mean by anomalous anymore. And what if you want to do it in real time? You don't want to put all the data in a data warehouse to look at an hour or a week or a year later, but you want to look at it now. And so this is why we need analytics and machine learning to solve this problem. The example I'm going to show you here is an example of one other trend in research. These advanced AI and data science techniques are often still very hard to use. And so one area of research that Peter and colleagues at Stanford are working on is how to make the most advanced techniques easier to use. We're still a few years away from buying Microsoft Office and having a machine learning module right alongside of Excel and PowerPoint. Although my guess is we're only a few years away from that, not many. But in the meantime, the researchers are trying to figure out how can you hide some parts of the complexity without dumbing down the technique. So this has been applied for people who run data centers. It was applied to a company who rolls out over-the-air software updates to electric vehicles. And in the example I'm going to tell you, an app developer for smartphones deployed the latest version of the app. And this is a small section of the real data that was generated with record identifications and serial numbers and locations and software versions and consumption of the battery. And what they found was when they rolled out the upgrade, a small subset of the phones that had received this new upgrade started discharging their batteries too rapidly. At the very least, that's going to give you an angry customer who says, damn, I downloaded your app and now my battery only lasts 4 hours before I need to recharge my phone. Of course, in the worst case, the phone gets hot and the lithium-ion battery might even burn or explode. One of the things that makes this difficult, this was Android phones, not iOS phones. This is a map of all the unique hardware, software versions in the Android phone universe, where each little colored box is a unique hardware, software combination. Imagine the problem of your poor software developer who's now expected to test the app to make sure it works properly in every one of those variants. I think there's more than 1,000 little boxes there. And there's just no way you're going to do it. And so here's the actual data. This shows the number of devices versus the battery consumption. And way out here to the right are those few devices that are consuming power at an unsafe rate. In fact, you can barely even see those blips above the horizontal axis. So I blew up the picture here, and you can still barely see it. It's a small fraction of 1% of all of the devices. And so this is a real hard troubleshooting problem. And what this software does is it allows the users through simple point-and-click pull-down menus to indicate what are the attributes we care about and what correlates should we look for. And in this case, in less than a second, it said that app version, hardware, make, and model seemed to be strongly correlated with rapid battery power consumption. And in fact, here in amber, you can see the distribution of devices for that particular hardware, make, and model, and you can see that, indeed, that hardware, make, and model seems to be correlated with the problem. And now that poor app developer of yours has a solvable problem. Now she can go look at that particular make and model and figure out why the software isn't working correctly. Or just put those devices back on the prior version while you work on it so they're not even exhibiting the problem anymore. And I want to switch gears and talk about what computer folks call natural language processing, the idea that computers can make sense out of human language. This is particularly relevant in customer service businesses, which in a way I think is every one of us, no matter what industry we're in, right? We all have customers, we're all trying to sell products and services, we're all doing customer support, whether we're in retailing and e-commerce or financial services and insurance or even manufacturing. And then the power of natural language processing is part of what's fueled during the last few years things like smart customer service, more effective prediction of customer demand, and a variety of other things. And I want to show you a little bit about what's happening at the cutting edge of natural language processing right now. But first, a humorous story about how it can go badly wrong. Some researchers noticed that when the name of the actress Anne Hathaway appears in the news, the stock Berkshire Hathaway tends to go up in value with increased trading. For those of you who are a little too embarrassed to admit it, Anne Hathaway and Berkshire Hathaway have nothing to do with each other. And so this is either a case of some phenomenally uninformed investors or some automated and not very intelligent natural language processing algorithms trading Berkshire Hathaway on news announcements of actress Anne Hathaway. Well, this was several years ago. Systems are getting better, and of course, once you detect something like this, you're not going to make the same mistake again. But let's take a look at where natural language processing is at today. This is an example of work that some of my colleagues are doing in sentiment analysis. The sentence, for those of you who can't read it from where you're sitting, comes from a Yelp review of a movie, and the sentence reads, "There are slow and repetitive parts, but it has just enough spice to keep it interesting." Now, most of us can tell readily that that's fundamentally a positive statement about the movie. This is a description of someone who liked the movie and thought it was a good movie. Computer natural language processing algorithms have traditionally had problems with sentences like this, particularly if they've used a simple approach called bag of words. Just count up all the words and their meanings and try to figure out if it's net positive or net negative. But by doing the kind of analysis shown figuratively in the diagram, the researchers were able to determine that this is fundamentally a positive statement about the movie. That's just one example, but in general, the ability of computer programs to not just get the literal sense right, but to tease out some of these subtle meanings is getting better and better. Let me tell you a little bit about some of the work on Yelp restaurant reviews. This is work by Dan Jarafsky and colleagues at Stanford, and they started by looking at 900,000 online restaurant reviews. They looked first at negative reviews, and they found that reviewers use the same kind of languages that people use when describing serious trauma. They use words like horrible, awful, terrible. They speak in the past tense, and they use words like we, us, and our. So this was some communal, horrific experience eating at this restaurant. And in fact, the language was the same sort of language that they find in things like campus shootings, the death of Princess Diana, and the September 11th attacks. Their conclusion is you can extract something about the psychological state of the writer from the things that she or he has written. Next, they took a look at positive restaurant reviews. And they found that for relatively inexpensive restaurants, reviewers often used an analogy of drugs. I'm addicted to pepper shooters. Garlic noodles are my drug of choice. The fries are like crack. But for more expensive restaurants, the allegory was to sex instead of drugs. And so here, for expensive restaurants, reviewers said things like orgasmic pastry, sexy food, and my favorite, seductively seared foie gras. I don't even know what that means, but someone wrote it. And while it's all pretty funny and entertaining, it does get at some of the power of language that we use all the time. And as computers can get better at extracting that, then all of us in business who want to take advantage of what our customers are saying in our call center blogs or in social media will be able to take advantage of things like this. Another colleague of mine, Yuri Leskovich, seeks to understand how information moves in massive networks like Facebook or Twitter. And I realize you can't read the curve from where you are, but the horizontal axis is dates, so time is moving from left to right. And each of these colored spikes is some comment that went viral on the internet about a company, about a person. And Yuri has applied this with the company Pinterest to understand customer purchasing intent. He studied how things become viral and propagate, and he's worked with companies to understand how their reputation evolves after good or bad events. In particular, he worked with Boeing. You all may remember that shortly after the Boeing 787 Dreamliner came out, there was a series of problems with fires in the lithium-ion batteries. And so one of the things he studied was how does that move through social networks, and how does a company's reputation get affected and then recover afterwards. Let's talk for a minute about computer vision. It's touching everything that we do, and the progress has been extraordinary. It's gone way beyond just finding cats on the internet. It's moved from identifying objects in an image to actually making sense out of a scene. It's not just some children and a birthday cake, but it's a child's birthday party. And once you're able to make sense out of a scene, think about it. You can actually predict the future, and you can actually tell a story about what probably happened immediately prior to the picture being taken and what's likely to happen a few minutes in the future. Of course, sometimes you have video, not just still images, and computers' ability to make sense out of videos is extraordinary. We can now analyze videos at 30 frames per second in real time. We can now analyze video feeds from city streets to find a crime taking place. We're probably not very far away from a computer watching you make spaghetti sauce in your kitchen once, and then the next time the robot will just do it and imitate what you did. By the way, we're not there quite yet, but that's probably where we're heading. Let me just show you a little bit about how this works. At first, the ability was to identify a cat in an image, and beyond that, multiple objects like a cat and a skateboard. And beyond that, understand contextually what's going on. It's not just a cat and a skateboard, it's a cat riding a skateboard. And the state of the art here now can start to get many more subtle features out of the image. In fact, if you take a look at this next picture, this is work by my colleague Fei-Fei Li and her coworkers, you can see that even in a cluttered image with things overlapping and poor contrast and bad lighting. By the way, all of these written things are from the computer. None of these are from humans. And the computer does a pretty good job of finding a lot of things going on there. It also makes some mistakes. You can see it says man wearing a black shirt, and the man's clearly wearing a red shirt. So you get a sense of what the state of the art is. This is relatively recent work, just a couple years old. But computers are now able to do this kind of thing with images. So what I'd like to do next is talk a little bit about how I think about combining these rapidly evolving technologies to business problems, how I often work with companies in doing so, and how you might think about crossing that chasm, making that leap from the kind of largely academic research I was just talking about to the real-world problems that you deal with at your companies every day. The sorts of things we're talking about provide opportunities for much greater insights, predicting customer demand, hyper-personalization, and so on. Improved understanding of our customers. By the way, that means our prospective customers, as well as our current customers, whom we might be able to serve better or upsell. It gives us the ability to act on individuals rather than averages. Often, if we're really good, we can identify parallel industries that are synergistic with our own, and I'll talk more about that in a minute. We can move faster. Increasingly, we can use data to discover things that we weren't looking for, as opposed to what we typically did with data in the past, which was to look in our rearview mirror and understand what happened in the last quarter or the last year. And of course, we've all recognized, our companies have all recognized that data is now a valuable asset. The same way human resources or capital or brand or physical plant are important. And this is leading to all kinds of consequences, both good and bad. It means that the data that you have has value. But as we realize, it's also leading companies to hoard data, and it's led to a highly non-uniform distribution of access to data, where companies like Google and Amazon seem to have an unfair advantage. In thinking about applying these technologies to business, I often find it helpful to think about a hierarchy of applications. Starting with using these technologies to get to greater operational excellence and efficiency. This is often within our IT organizations. Once you've done that, the next thing that you might seek to do is try to develop improved products and services, better ways of doing the things you're already doing. But if you stop with just those two, you're probably missing the most disruptive opportunities, and you can be assured that the startup that's your would-be competitor is going to be thinking about the next two. So the next one is to think about entirely new products and services. This is hard, and one place to look for them is often in adjacent industries. So if you're a bank, maybe there's a synergy with insurance. If you're selling, I don't know, consumer goods in e-commerce, maybe there's a connection with how you service and use those goods after they've been sold. Identifying new products and services can be a great way to increase competitive advantage. Hardest and most scary for most of us of all is to try to identify entirely new business models. And you can think of examples of this. This often happens when companies redefine their role as a company or who their customer is or the way they provide value. And so the traditional taxi industry was disrupted by Lyft and Uber. The traditional hotel industry by Airbnb, and I'm sure you're all thinking of other examples. I find it pretty hard to make sense out of all of this in the abstract. So often when I work on this, I work with individual companies in specific industries, and I wanted to give you at least a taste of that. In the financial services business, we often talk about ways to do smart customer service with better sales recommendations, better problem solution. We talk about more effective demand forecasting and hyper-personalization. We're also seeing increasingly lately companies care more and more about their reputation for being companies of integrity that care about humanitarian issues and society, and increased concern that these systems are accurate and fair and free of bias and will work properly even in unexpected circumstances. So looking forward, what are some of the things we can expect to see? We're going to see a continued trend towards making advanced techniques easier to use. Increasingly, these techniques are going to be something that we use in an interactive way where they augment our decision making. I don't think many people are going to lose jobs from these kinds of things. I think these are going to become our new tools, much like our spreadsheets and calculators are today. We're going to see more personalization. We're going to see more contextual and human-centered interactions. Security and privacy are going to continue to be better protected, and with a little luck, one day soon, none of us will have to remember passwords anymore. That would certainly be nice. And we're seeing a lot more interest in education. I think this is part asking if education can help with job loss from people who are going to lose jobs due to automation, like truck drivers. We need to be able to retrain these people. But also people like us and our colleagues in our own employers want to get training in these advanced techniques as they emerge. Thank you very much.